Okay, now we start to find how to find a value to be loaded in the timer. As I mentioned earlier in the previous slide, okay, there are three or four equations that you need to remember in order to calculate your TC and T value. Right. So in this case here, we want to find how to find the value you want to be load to your TC and T. So first thing first, you need to assume that the amount of time needed is known. Okay, so given that the delay that you want to generate is known, then you need to find the value needed for the TC and T register. Okay, by using this following step to calculate the value to be loaded into TS and T, first thing first, what you're going to do is you need to find what is your period. Okay, so calculate the period of the timer clock using the following formula. What is the formula here? T clock equal to 1 over F, in which F is your frequency, okay, of your timer, or sometimes we call it as your ester, your oscillator frequency, and etc. Right? So if you using no prescaler mode, means that the F timer sama dengan F oscillator. Okay, so means that if no prescaler is used, means that you just take the external F. If you using the oscillator, the prescale, then you need to divide it with your prescale value to get your new F, right? And then next you are going to do is, all right, this is the first equation that you need to know. The second equation is that, okay, delay equal to count multiplied by period. All right, so you already know what is your T, and then now you want to find what is your count, in which you already know the delay, right? So you already know the delay, you get the period, then you need to find what is your count. Yeah, once you get your count, what happens is you can use this formula here, TC and T equal to FF minus count plus 1, in which this FF here you can change to 255 minus count, the count that you get from this equation 2, plus 1, then you get what is the TC and T value. But this one here, if you're using the overflow method, if you're using the CTC method, what you're going to do is OC, okay, OCR equal to T and T plus with your count minus with 1, in which TC and T for the CTC mode we always set at 0. So you already have the count that you calculate from the second equation. Then you get your what is your OCR, which is the level that you want to set. So that when the TC and T equal to OCR, the flag will raise, and then you already generate the delays. Alright, so let's look at this example here. Okay, you're going to find a value to be loaded in the timer, assuming that the ester is 8 megahertz. Okay, you know that your ester is X megahertz, so your F frequency is 8 megahertz. Okay, write a program to generate a square wave with a period of 12.5 microsecond on pin port B. Okay, so you're going to generate a square wave, in which in this square wave here, okay, consists of logic 0 and logic 1, and at the same time here it tells you that this square wave here, right, the square wave here, the period of the square wave, which is, okay, so you know that this the period of the signal is consist of the positive cycle and negative cycle, which is a one complete cycle. So this one here, the period is 12.5 microsecond. Okay, so what you're going to do here? So since this square wave here consists of logic 0 and logic 1, so you need to find what is the time okay, between logic 1 and logic 0. Okay, for each of this logic 1 of logic, so this one will become your delay that you want to generate in your program. So since this one here, you know that the period of the signal is, okay, which is the, I call it as a T signal, sama dengan 12.5 microsecond. Since this logic 0 and logic 1 here, okay, okay, is the time here is same, so you can divide it by 2. Okay, so you know that the delay, right, the delay for each of this logic 1 or logic 0 here is 6.25 microseconds. Okay, so by using the first more formula, okay, what is the first formula say? T equal to 1 over F. Okay, don't mix up this T here. This is for T clock, while this T here, this is for T signal. They are different things. Okay, not the same things. Okay, this is a T clock, while this is the T signal. Alright, so since T equal to 1 over F, then you get your 1 divided by 8 megahertz. Alright, because this one here we're going to write a program, okay, write a program, okay, that use a timer 0, normal mode with no previous. Okay, so what you're going to do is, okay, so this one here 1 over F sama dengan megahertz, so you get 0.125 microseconds. So this is the T that you generate, alright, by using this frequency here. Then what you're going to do is the second formula, okay, which is delay equal to count, okay, multiply with T, okay, the period that you get earlier from equation 1. So what happen is you're going to find what is your count value. Count sama dengan delay. What is your delay? Delay that you want to generate is 6.25 microsecond. 6.25 microsecond darab dengan, sorry, divided with 0.125 microseconds. Then you get how many counts here? You get 50 clocks cycles. Okay, the count here is 50 times. Or sometimes we call it as a 50 clocks. Okay, then the third step you're going to use is the third equation. Since this is a normal mode, so you can use the TCNT sama dengan 255, or sometimes we use a FF. Okay, minus with count. What is your count? 50 plus with 1. Alright, so 256 minus 50 equal to 256 minus 50, you get 206. Okay, equal to 206. Okay, or you can change this one here to hexa equal to C. So this is the value that you're going to load to your DC. Okay, so now we're going to write the program. Okay, what's the program say? Okay, first, okay, so this one here, I think this one you can write it by your own, because I don't want to focus on this part here, because in this, because you already know how to initialize the port B, what is the, what we call here, the header that you are going to use, and then how to make a square wave, so forth. Okay, so I just skip this part. Okay, and I just want to focus on the delay subject. Okay, so void T0 delay. So this one here, you can name it any name that you want. Okay, so make sure that this name here sama dengan this name and sama dengan this name. Okay, and then first, what is the first step when you're going to write down your program? Okay, first you're going to load your TCNT. So since this one here we using a timing 0, so TCNT 0 equal to 0xCE, or sometimes you can put TCNT 0 sama dengan, you can put this decimal value as well, 0.206. Okay, next TCCR 0. Okay, the second step here is your TCCR setting. Okay, so make sure that the TCCR setting is correct. So in this one here, you're going to use the timer 0 normal mode with no prescale. Okay, so remember back your TCCR. Okay, which are the bit that you need to set. Okay, so in this case here, for the timer mode, you're going to set bit 6 and bit 3, in which for normal mode you put 0, 0. But about the prescaler here, okay, since you're not using a prescaler, so you're going to put a 0, 0, 1. Okay, so the rest you just put 0, 0, 0, which is equal to sama dengan 0, 1 in hexadecimal. So that's why TCCR0 equal to OX0, 1. Or sometimes you can use TCCR0 equal to 0B. You can use the binary number because you, okay, so that you not mix up with the value. Okay, so you know that this one is 0, bit 6 is 0, 0, 0, bit 3 is 0 because you're going to use the normal mode, while the rest of these 3 bit is 0, 0, 1 because you're using a no prescale option. Okay, and the third step here, you're going to monitor your timer flags. Okay, this is the first step. Second, third step, how to monitor your timer flag. Always memorize this what we call here, this line here. Okay, while open brackets here, TIFR, and with the value or the flags that you're going to monitor. Since this one here, we are going to monitor TOV0. Okay, so you need to locate, okay, where is your TOV0 located in your TIFR. Okay, since T0V0 is located at bit 0, so that's why you put OX0, 1. Is it equal to 0? If yes, it keep looping. If not, what happen is it will, okay, when your TIFR, which is your T0V0 bit equal to 1, what happen? Okay, it will exit this while loop, and then the fourth step here, you're going to stop your timer. How to stop your timer? By using the TCCR0 equal to 0. Okay, because to stop a timer, you need to make sure that this 3 bits here equal to 0, 0, 0. So you're going to stop your timer. Okay, and last but not least here is step number 5. You are going to clear your TOV0s because just now your TOV0 equal to 1. So how to clear that? You just put TIFR equal to OX0, 1, or sometimes you can put TIFR equal to 0B0, 0, 0, 0, 0, 0, 0, 1. This is the location of your TOV0. Okay, so this is how you're going to write a program for your timer 0 by using a normal mode with no prescale method. Okay, so what you're going to do is you need to find what is your TCNT, do the calculation. After you do calculation, then you follow the step on how to program your timer 0 by using a normal mode and no prescale. Okay, so you just follow the step that I gave you earlier. Okay, and then prescaler and generating a large time delay. Okay, previously the size of time delay depending on two factors. First is the crystal frequency or your external frequency. Okay, either you use a 1 megahertz, 8 megahertz, so it depends on your what we call here, depend on your frequency lah, external frequency. And the second one here is the timer counter register size. Okay, is it your timer counter, your TCNT is 8 bit? If 8 bit, it can support only until 255, which is FF. If you're going to use a 60 bit timer, so it can support until FF, which is around 65,000 something. Okay, so it depending on these two factors here. First, your frequency, and the second one is your TCNT size. Right? Either you use a 8-bit timer or 16-bit timer. In Amiga 32, we only have two options: 8-bit timer, which is timer 0 and timer 2, while 16-bit timer is for timer 1. Okay, in which the largest time delay only achieved by making the TCNT 0. Okay, so how to get a largest time delay? By using a overflow method. Okay, earlier. Okay, to make a largest time delay, what you're going to do is you need to empty your TCNT. Okay, so you just empty your TCNT, put the water, and you can generate the last timer delay. Okay, suppose if you have a bottle and then you put the TCNT, so this is your TCNT, and then this is only the delay you generate. So this is the maximum delay because you empty your bottles, which is you put the TCNT equal to 0, and then you put the water, and this is your delay that you generate after the water overflow. Okay, equal to this one here. Okay, compared to this one, okay, you put the TCNT value. Okay, for example lah, this TCNT. Okay, let's say lah. Okay, earlier we already put that this is a 1 liter. Okay, this bottle here 1 liter, and then the water here. Okay, the flow rate here is 100 milliliter per second. If you put your TCNT or your water bottle empty, and then you put the water, and this one here you can generate a 10-second delay. Compared to this one, let's say like you put your TCNT here. Okay, you put 200 ml. You already put 200 ml, 200 ml. Okay, so what is the delay that you can generate? Only 8 seconds. Okay, because this one here you have another 800 ml to fill out the water. Okay, so let's say lah, if you already put the TCNT equal to 0, okay, and then what if that delay is not enough? What you're going to use? Okay, in this case here, we are going to use the prescaler option to increase the delay by reducing the period. Okay, so the prescaler option allows us to divide the instruction clock by factor of 8 to 1024. Okay, so this is your timer counter 0 prescaler. Okay, if you can see here, this is your CS00, 01 and 02, which is this is kosong, bit 1, bit 2 in your TCC R0. Okay, recall back, this is your TCC R0. Okay, bit 6 and bit 3 is your timer mode setting, while this one here is your prescale option. Okay, if you put 000, what happens is you stop your timer. If you put 001, what happens is, okay, no prescale use. If you put 011, okay, 000, stop timer. 001, no prescale. If you put 010, what happens if you put 010, okay, which is you use a prescale of 8. Okay, 011, so you using a 64 prescaler. 100, you're using the 256 prescale. 101, you're using a 1024 prescaler. When you use the 110 or 111, so this one here, okay, which is you use the to generate a event, okay, to count an event. Okay, so previously with no prescale enabled, the crystal oscillator frequency is directly fed into timer 0, means that your f equal to your xtel, or sometimes your f equal to your oscillator frequency. But if the prescale bit is enabled, you need to divide the clock before it fed into your timer, means that you need to, okay, find your new f new equal to your xtel divided with your prescale. Okay, so the lower 3 bit of TCCR0 will give you option of the number we can divide by 8, 64, 256 or 1024. Okay, so let's look at this example here. Find the timer clock frequency and its period for various AVR-based systems with the following crystal frequency. Okay, given that the xtel is 8 MHz, 60 MHz, 10 MHz. Assume that a prescaler of 64 is yours. Okay, for A, what you're going to do? Okay, so you're going to find what is the frequency and period. So first, what you're going to do is you need to find what is your new f. Okay, new f equal to 8 MHz. Okay, for A sama dengan f equal to, okay, what is your current xtel? 8 MHz. Okay, so you need to divide with your prescale. What is your prescale? 64. Then you get 125 kilohertz. Okay, then from here, T equal to 1 over F. Okay, so this F new, F new, so equal to 1 divided with 125 kilohertz. So you get 18 microseconds. Okay, what about B? Similar lah. You need to find what is your F new, which is by using the 16 megahertz, okay, divided with 64, and you get 250 kilohertz. Okay, and then T over F, so you get 4 microseconds. Okay, next is 10 megahertz. Alright, so 1 divided with 64 multiply with 10 megahertz. So for C sama juga lah. Okay, F equal to 10 divided with 64, so you get 1.562 kilohertz, and then from here you get your T over F equal to 6.4 microsecond. Okay, if you can see here, the smaller the frequency, the smaller the frequency that you use, the higher, okay, the higher that time you can generate, the delay that you can generate. Okay, so let's do another example here. Find the value for TCCR0 if you want to program timer 0 in normal mode. Okay, you're going to use a normal mode with a prescale of 64 by using internal clock for the clock source. Alright, so again, okay, so this is your TCCR0, consists of 8 bits. Okay, so you need to focus on bit 6 and bit 3 for timer setting. Since this is a timer 0 normal mode, so you just put 0 0. But here on the pre-scale part, okay, you're going to use a 64. Okay, so what is your 64? Okay, so you need to go back to this slide here. All right, ataupun to this slide, just refer back to this slide. Okay, then you know that for the mana side. Let me show you the slide first. Okay, so just go to this slide and find what is the value of 64. So the value for 64 is 0 1 1. Okay, so you just put 0 1 1. Okay, 0 1 1. What about the rest? Okay, so just put 0 0 0. So how to program? Write a program. TCCR0 equal to 0B00000001 ataupun, or you can put TCCR0 equal to 0x03. Okay, so means that you use a timer 0, normal mode or overflow mode, okay, and with a prescale of 64. Okay, let's look at another example here. Okay, assume that the Excel is 8 megahertz. Okay, find the clock period fed into timer 0 if a prescaler option of 1024 is chosen. Okay, so you're going to find what is the period that going to fed to your timer 0 if prescale option of 1024 is chosen. Okay, so A, first your Excel is 8 megahertz. So what you're going to, and then you're going to use a 1024 prescale. So what you're going to do is you need to find the F new. Okay, your new F equal to, okay, current F, your Excel value at megahertz divided with prescale, then you get 7812.5 hertz. Okay, then after that you're going to find what is your period. Okay, it's your T clock. Okay, your T clock period equal to T over 1 over F. What is your F? This is your F 7812.5 hertz, and then you get 128 milliseconds. Okay, B, show what is the largest time delay we can get using this prescale option and timer 0. Okay, you're going to find what is the largest time delay. How to obtain the largest time delay? To obtain the largest time delay, you need to put your TCNT equal to 0 lah. You must left your water bottle empty before you put the water inside. Okay, so how to do that? You know that. Okay, so now you're going to find what is the delay. Okay, so you know that delay, equation for delay is delay sama dengan, betul, count multiply with period. Okay, you already know the period. Okay, then you need to find a delay. What about count? Okay, you can find what is your count value. How to find your count value? By put TCNT equal to 0. Okay, so you just put in equation number 3, TCNT sama dengan 255 minus count plus 1. Okay, you put this one here equal to 0. So what happened is your count equal to 256. Okay, plus with TCNT 0. Okay, so your count is 256. Okay, so you put into this equation 2, what happen is count is 256 multiply with your period is 1 to 8 millisecond. So the largest time delay that you can generate by using timer 0 with a prescaler of 1024 is 32,768 microsecond, or equal to 0.03276 second. Okay, so this is the largest time delay that you can generate by using frequency of 8 megahertz as the frequency of 8 megahertz with a prescale option. Let's look at the another what we call here example. Okay, assuming that x still equal to 8 megahertz, write a program to generate a square wave of 1 to 5 hertz frequency. Okay, square wave of 1 to 5 hertz frequency. Okay, so based on this, what we call here, based on this information, okay, you know that x still is 8 megahertz and the square wave from frequency, okay, frequency of your signal equal to 1 to 5 hertz. Okay, so you're going to generate a square wave. Okay, and then what it's going to do, using a timer 0 normal mode with a prescale of 256. Okay, first thing first, okay, you need to find out what is your T signal. Okay, because we have the F signal. Okay, this one jadi is your external punya frequency, and then you have another frequency which is your signal punya frequency. So you can find what is your T signal. Okay, T signal equal to 1 over F, which is sama dengan 1 divided by 125, you get 8 millisecond. Okay, so this is your T signal. Okay, from one complete cycle, so you know that this is T equal to 8 millisecond. But since this one here, you're going to generate a square wave, okay, in which your square wave consists of logic 1 and logic 0 equally. Okay, equal logic 1 and logic 0. So you know that this one here for logic 1 is 4 millisecond, this is another 4 millisecond, and you get a total of 8 millisecond. So this is your delay that you want to generate in your programs. Okay, next, what are you going to do? Next, you have a external frequency is 8 megahertz, but in this case here, you're going to use the prescale of 256. Okay, so what you're going to do is F new equal to 8 megahertz, okay, divided with 256. Okay, then you get, so this one here you get 31 point 31.2 kilo, sorry, 31.25 kilohertz. Not highlighted. Eraser. 31.25 kilohertz. Okay, that is your F new. Okay, from here you can get your T, your T clock. T clock sama dengan 1 over 31.25 kilohertz. You get okay, so T equal to 1 over your frequency that you get after you do the prescale. Okay, so you get here is 0.032 millisecond, or sometimes you can put 32 microseconds. Okay, so this is your T. Alright, so this is your first equation. Second equation is delay equal to count multiply with your period, okay, your T clock. Okay, so since you already know your T clock, which is 32 microsecond, and delay that you want to generate is 4 millisecond, then you get a count equal to, what is your delay that you want to generate? 4 millisecond divided with 0.032 millisecond, which is equal to 1 to 5 times. Okay, so this is your count, 125 times. Okay, next what you're going to do is using a third equation, T, C and T sama dengan 255 minus with count 1 to 5 plus with 1, so you get 131, or equal to hexadecimal of 83. So this is the value that you want to put to your T, C and T. Alright, so based on this one here, what you're going to do is, okay, you're going to write your program. So I only focus on the delay subroutine program. Okay, the top here you just figure out how to do it, because this one is we already did in the previous examples. Okay, we have a lot of example to how to initialize the port and how to make a square wave and etc. All right, so void to delay, so this is a delay subroutine. Okay, make sure you name the label. You can use any label or any names here. Okay, make sure that this name here sama dengan this name and some equal to this name. Okay, so first step, what you're going to do in first step, okay, initialize your TC and T0. Alright, so TC and T0 equal to OX883. Okay, we already calculate here. So the value that we need to put in our TC and T is 83 in hexadecimal, or you can put TC and T0 equal to 131. Okay, 131. Right, and then this is your second step, your TCCR setting. So what is the TCCR setting that you're going to use? Okay, in this case here, you're going to use the timer 0, normal mode, and prescale of 256. So how to do that? Okay, so again, okay, this is your TCCR 0, bit 6 and 3 you just put 0 0 because you using a normal mode. What about this prescale here? Okay, so prescale, you need to make sure the prescale is correct. So for this one here, okay, for 256 prescale, you need to put 0 1. Is it 0 1? No, 1 0 0. Okay, you can always refer to this table here for the prescale option. Okay, for the 256, mana kita punya prescale option. Okay, for the 256, the value that you need to put is 1 0 0. Yes, so the rest you just put 0 0, and this is the value that you can put, which is equivalent to 0 4. Okay, so TCCR 0 equal to 0x04, which is you use a timer 0 normal mode with prescale of 256. And then number 3, monitor your TOV0 flag. Okay, so you can put while TIFR end with 0 at 01 is it equal to 0. If yes, then you keep repeating. If no, it will. If the TOV0 flag equal to 1, what happen is you exit this while loop and stop your timer by putting TCL0 equal to 0. And then step number 5 here. Okay, clear your TOV0. Okay, how to clear TOV0? By putting 0 at 0 1 to your TIFR. Okay, that is for the timer 0 normal mode programming or overflow programming. Okay, next we are going to see how to program for the compare mesh or CTC mode. Okay, in this CTC mode, the OCR0 register is used, okay, to compare the value with your TCNT. Okay, so OCR here is used to compare with your TCNT, your counter register. Okay, if the OCR equal to TCNT, what happens is your OCF flag will be set 1. If not, you keep monitoring your OCF flag until your OCR equal to your TCNT. Okay, so as in the normal mode, in the CTC mode, the timer is incremented with a clock. Sama juga. Okay, CTC mode, normal mode, the timer is incremented with your clock. Okay, the timer will incremented based on your frequency. Okay, which is your period lah that you calculate from your frequency. But it count up until the content of TCNT0 equal to OCR0. Okay, then the timer will be cleared and OCFO flag will be set. Okay, so this OCFO flag is located in the TIFR register. We already learned about TOVO flag, OCF0 flag, and as any other flag that located in your TIFR. This is what happened lah. Okay, first you set your TCNT with 0. Okay, and then this is your OCR. Okay, the timer that you want to generate. Okay, you just put your OCR with any value that you want to generate. If the TCNT equal to OCR, what happens is the OCF flag will equal to 1. Okay, and then it will reset and it will keep repeating. Okay, so this one here will be done periodically. Okay, let's look at the example here. Okay, in the following program, we are creating a square wave of 50% duty cycle with equal portion of high and low. Okay, again, you are creating a square wave. Okay, with a portion cycle of high and low. Okay, which is this logic 1 and logic 0. The delay here, okay, the delay that you want to delay logic 1 and logic 0 are equal lah. Okay, so X. This one also X. Then on port B, pin number 5, timer 0 is used to generate the time delay. Analyze the program. Okay, so this one here, this part here, okay, I will skip this part. Okay, now I want to focus on this part here. Okay. So in this one here, since this is your what we call, you're going to write your program in CTC mode. Okay, so you need to do a modification to your step how to program your timer. Okay, so in this CTC mode, the first step that you're going to do is, okay, clear TCNT. Okay, so you're going to clear your TCNT. Okay, make your TCNT equal to 0. And then second one is load OCR value. Okay, so this is the TCNT end. This is OCR end. You can apply to any of your timer. Is it timer 0, timer 1, or timer 2? You can use this step here. Okay, step number 3, TCCR and setting. Okay, set your timer accordingly. Okay, and as well as your prescale. Step number 4, monitor OCF flags. Okay, you're going to monitor your OCF flags. Step number 5, why step number 5 is stop timer. Sama juga. Okay, after your OCF equal to 1, then it will exit this loop here, while loop here, and you're going to stop your timer. And step number 6, clear your OCF flags. Okay, so you have one extra, actually you have one extra step, which is this one here. Okay, you're going to clear your TCNT. Previously we load the TCNT with value, but this one we need to clear the TCNT, and next you need to load your OCR value. Okay, so in this case here, okay, this is the first step. Okay, clear your TCNT, load this OCR, this is the second step, and this is the third step. Okay, TCCR0 equal to OX09. Okay, so this is your TCCR0. Okay, so you need to find out what is the timer setting that you put to this program here. Okay, so since this is the TCCR0, so you know that you use a timer 0. Okay, so this 0, 0, 0, 0. So this is for 0 and 1, 0, 0, 1. Okay, so this is bit 6 and this is bit 3. Okay, so you see here for the bit 6 and bit 3, the setting is 0, 1. So you know that you're going to use the CTC mode. Okay, what about the prescale? Is there any prescale that you use? Since the value bit here is 0, 0, 1, so you know that no prescale is used for this example. Okay, so you can know that using a timer 0. Why? Because you use the TCCR0 with a CTC mode and no prescale. Okay, this is step number 4. Monitor your OCF flag. Okay, so while TIFR and with, okay, check is it your OCF0 equal to 1. Okay, this is similar, sama juga lah dengan earlier that we write. Okay, but previously we put the 0x01 for the TOV0 punya flags, correct? But this one here, okay, since we are going to monitor the OCF flag, so you need to find out what is your OCF punya location. Okay, so you refer back to your TIFR register. Okay, where is my TIFR register? Okay, TIFR register. Where is my TIFR register? Okay, so this is my TIFR register. Where is my OCF0 flag? Here, at bit number 1. So in bit number 1, so what is the value that I need to monitor? 0, 0, 0, 0, 0, 0, 1, 0, which is equivalent to 0x0. Okay, so okay, you can write something like this, or you can write, if you're comfortable to write something like this also can, or you can always write y TIFR and with 0x. Okay, what is the location of OCF0 just now? 0, 2. Is it sama dengan kosong? Okay, you can also write something like this. Okay, depends on you. Which one you comfortable most? Okay, either this one here or this one. For this one, you need to know lah the location of your OCF0, but this one you no need to know the location. Okay, you just put the, okay, put 1 to your OCF0 punya location. Right? And then after that, step number 4, this is step number 4. Step number 5, okay, stop the timer. Okay, how to stop the timer? TCCR0 equal to 0. And step number 6, clear your OCF0. Okay, you can put TIFR equal to OX02, ataupun, or you can write down TIFR. Okay, if you don't want to Now to memorize the location, you can always write TIFR, okay, is equal to put 1 to your OCF0. Also can. Okay, you can use either way of the program instruction. Either you use the value or you put something like this, depending on you. Okay, which one you comfortable about. Okay, sama juga lah, similar to this one here. Alright, so in this case here, okay, you can rewrite this one something like this: y TIFR, and with put 1 to your TOV0, is it sama dengan kosong, and this one you can replace with TIFR equal to put 1 to your TO0. Okay, the difference is this one you need to know the names of your flags that you want to monitor and the flag you want to clear. But this one here, okay, if you're using this kind of programming, so you need to know the location of your TOV0 flags. Okay, so the value here will be different depending on the flags that you're going to monitor and clear. Okay, so this is what happens. Okay, you can read it by yourself. Okay, so let's look at this example here. Alright, assuming that X is 8 MHz, write a program to generate a delay of 25.6 milliseconds using a timer 0 CTC mode with a prescale of 1024. Okay, so given that X sama dengan 8 MHz, prescale 1024, timer 0 with what we call here with a CTC mode. Okay, first thing first, before you write down your program, okay, what you're going to do. Okay, so first thing first, since this one here you using a prescale, so you need to find what is your F new. Okay, satu lagi we forgot. Okay, the delay that you want to generate is 25.6 millisecond. So F new equal to 8 MHz divided with 1024. Okay, now F new equal to 8 MHz divided with 1024, then you get this one here, 7.8125 kilohertz. This is your new F after you do the prescaling. Okay, then next what you're going to do, you need to find out what is the value that you want to put to your OCR lah, because this one we use a compare mesh. Okay, so you need to know what is your OCR value. So how to find a OCR value? So you need to you do a calculation. Okay, the first one here is you need to find what is your T. Okay, T equal to 1 over F, di mana equal to 1 over 7.8125 kilohertz, you get 0.128 millisecond. This is your T. Okay, after you find out what is your T, okay, you can put to your second equation, which is delay equal to count multiplied with your period. Alright, so you know the delay that you want to generate is 25.6 millisecond, while T here is 0.128 millisecond. Then you can get what is your count. So counts equal to delay to 5.6 millisecond divided with 0.128 milliseconds. Then you get what is your count value, 200. Right, so next this count here 200 times. Okay, next this one here, you when you get this count here, what happen is you need to replace it or put it to your third equation, which is for the CTC mode. Okay, we are going to use the OCR equal to TCNT minus with count plus count minus 1, in which the for compare mesh the TCNT value always 0. So 0 plus with 200 minus 1, you get 199. So this is the value that you want to put to your OCR. Alright, so now we look at our programming here, how to generate this delay. So this is your subroutine punya delay that you want to generate. Okay, so the first one here, TCNT equal to 0. Okay, first clear your TCNT. This is the first step. The second step here, load your OCR value. So OCR 0 equal to what value that you want to put load is 199 that you already calculate here. So 199. And then the third step here. Okay, this is the crucial part. Okay, so you need to identify what is the value that you need to put to your or TCC R0. Okay, since this one here, okay, you're going to use the CTC mode, so make sure that bit 6 and bit 3 you put 0 and 1. Okay, so what about the last 3 bit here? For the free scale, since you're going to use the 1024, okay, so recall back 000 is stop, 001 no prescale, 010 D is berapa? 8 bit, 011 D is 60 bit, 100, so D is it correct? 256 100, if not mistaken, is 256. Mana kita punya ni table, right? Sorry, 011 is 64, 100 is 256, and followed by 1014 1024. Okay, here. Okay, this is 64. This is 256. 101. This is 1024. Okay, so you need to put 101. So what about the rest? You just put 0. And what is the value that you want to put here? 0 is 8 plus 4 is 12 plus 1 is 13. 13 is D. Okay, 13 is D. So this is the value that you're going to put to your TCCR, which is TCCR 0 equal to 0 at 0D, which is you use using the timer 0 CTC mode or with prescale of 1024. Okay, if you don't want to write down in hexa, you can always write down in binary. TCCR 0 sama dengan 0B0000 and 1101 also. Okay. Right. Next, step number 4, you're going to monitor your OCF0 flag. Why OCF0? Because you're going to use the compare mesh on the timer 0. So while TIFI and we put 1 to your OCF0, is it equal to 0? If yes, it will keep monitoring. If not, then you exit the while loop and stop your timer, okay, by putting 0 to your TCR0. And last but not least, step number 6, TIFR equal to 0x02. Okay, or you can write down TIFR, okay, put 1 or to your OCF0 also. Okay, so that is for the timer 0. We already covered how to write down in overflow method or normal mode and how to write down in CTC mode. Okay, next we are going to see what for timer 2 programming, how to write down in timer 2 programming. Right, since this one here for the timer 2 programming, since the timer 2 is a 8-bit in Atmega, therefore it works the same way as timer 0. Okay, so the the way you're going to write down your program is similar to your timer 0 programming. Okay, so you just follow the step, and then you can do your timer 2 programming. But there are two differences between timer 0 and timer 2, okay, in which timer 2 can be used as a real time counter. In timer 2, more prescale option can be found. Okay, that is the difference between timer 0 and timer 2. Okay, if you see here, this is your TCCR2. Okay, this is your TCCR2 because you're going to use the timer 2. So, of course, this one here you're going to use the TCCR2. Okay, so in the TCR2, you have more prescale compared to your timer 0. Okay, in which you see here 000, stop your timer, 001, no prescale, and then 010, you have prescale 8, 011, 32, 64, follow 1, 128, 256, and 1024 when you put 111 to your the last 3 bit. Okay, the position also same. Okay, bit 6 and bit 3 are used to determine, right, the mode that you're going to use, while the last 3 bit here is your prescale option. Okay, you have extra prescaler here. If you can see here, you have a 32 prescaler, which is you don't have in your timer 0, as well as 1 to 8 prescaler. Okay, so that is the difference between timer 2 and timer 0.